Thanks for joining. And today we are going to look at how to specify concrete masonry units, your project. In our TMS 602, which what we're looking at is Article 1.4 of our TMS 602, which is our specification for masonry structures. We have two methods for determining compressive strength, the unit strength method and the prism method. And in general, for projects in Michigan, we recommend using the unit strength method for establishing our compressive strength. And so usually where we're going to specify this would be either in our specifications. And so normally under the product section of our specification, we are going to list ASTM C90, which is our ASTM for load-bearing concrete masonry units. Might need to specify a density, and typically we're going to specify a compressive strength, which is what we see here in bullet point 2. So normally this is going to be in our specification, and it typically also shows up in our structural general notes. So in our first couple structural sheets that are issued as in the project drawings, for instance, on this project, it says masonry 28-day compressive strength F prime M equal 2000 PSI. And it also says concrete masonry units 2000 PSI according to ASTM C90. And so how do these two things relate? Well, if we look at ASTM C90, which I have here, the 2016 edition, we have table 2, which gives us our strength, absorption, and density requirements. And we can see here that our minimum net area compressive strength for our units themselves, the average of 3 units is 2000 PSI. And so that's our minimum for our unit strength for our actual concrete masonry units in ASTM C90. And so how does that relate to our specified compressive strength? Well, if we go back to our TMS 602 and we're using the unit strength method, they have tables for both clay masonry and concrete masonry. And so for concrete masonry, it says use table 2 to determine the compressive strength of concrete masonry based on the strength of the unit, which again is 2000 PSI minimum, and the type of mortar specified, as long as we meet these 3 criteria. And so going to table 2 here, we see that if we have a 2000 PSI unit and we use type S mortar, then we get a net area compressive strength of 2000 PSI. And so that would be our minimum that we can use in design. However, oftentimes our concrete masonry units have strength that exceeds 2000 PSI. So how do we interpolate these values? Well, if we look at a block test report, so for example, this is from one of our members, Consumers Concrete. This was sampled back in March of 2024. And we can see here that Soils and Structures did the testing, and the average compressive strength of these 3 medium weight units was 2,620 PSI. And so if we look at our table, we're at 2,620. So we're right about at 2,250 for our actual net area compressive strength of concrete masonry. If you wanted to know the exact value, you can go to the Concrete Masonry and Hardscapes Association. And on their website, they have a CMU unit strength method calculator. And so if you download that Excel sheet, which we also have a link to on our website, you can input those values. And so in here, they do have an instructions tab, and then they have tabs for the 2013 and 2016 editions of the TMS 602. And so if we had that compressive strength from our concrete test report of 2,620 PSI, we can see that if we linearly interpolated table 2, we would have an F prime M of 2,260 PSI with that particular unit. If we looked at another test report, for instance, this one comes from Best Block, another one of our members, and this is for a normal weight concrete masonry unit. You can see here the average compressive strength is 5,100 PSI. And so again, if we go back to our calculator here, we can plug in 5,100 and it's going to calculate an F prime M of 3,000 PSI. And that's because that's as high as the table goes here in the TMS 602. So how do we figure out, for instance, if maybe we're designing a project and we have high axial loads or high shear loads, and maybe we need a higher specified compressive strength of masonry higher than 2000 psi? Well, in the spreadsheet for from CMHA, if we needed, let's say, an F prime M, again, that specified compressive strength of masonry of 2500 psi, we can plug that in over here. And we see that we need a unit strength of 3,250 psi. And so if we needed a higher F prime M in our design, or we wanted to design with the actual units that will be used on that project, we can come in here and see what the required unit strength would be based on our F prime M that we used in design. In general, 2000 psi is going to be adequate for our projects, but as you can see, there's quite a bit of variability in unit strengths. And so sometimes we might want to take advantage of that inherent strength of our concrete masonry units. So hopefully that makes sense. If you ever have any questions, as always, please feel free to reach out to the Masonry Institute of Michigan. Thank you for your time.